Alright, so look at this interesting question. We've got like three of them that we just have to like answer from here. So I have to find the first four terms of expansions of the given. How do you go about it? So basically this involves you to apply the concepts of binomial expansions, okay? And we'll see how. So let's look at the simplest one, which is like the first one. For the first one, we have 1 plus x divided by 1 minus x. And for this one, the numerator, which is 1 plus x, can be multiplied by the denominator. The denominator can become the numerator by putting it in brackets, and then the power becomes a negative 1. That's all. Now from there, you will now have an idea of what you do there, right? You have an idea of what you can do. This remains as it is. Now we would have to expand this in a term that we're able to understand. Okay? Any idea on how we can expand that? Of course, you know. I already introduced you to these expansions. 1 plus nx plus n minus 1 to factorial x squared. So apply that. Now they want the first four terms. It's simple. The first one is obviously going to be a constant. Then the rest will be the power x to the power 1, x to the power 2. So go all the way up to x to the power 3 for us to get the first four terms. So let's try to expand that. So we have 1. Let me just start from the end there. So we have 1 plus our n is negative 1. So let me just remove that. So negative 1 multiplied by x is negative x, and then plus our n again is negative 1, and then n minus 1. Our n again is negative 1. So if we plug in negative 1 minus 1 there, let me just write it as it is. So negative 1 minus 1, and then our x is negative x squared. Our denominator there is 2. So dividing by 2, I already said it's as good as multiplying by 1 over 2. Since 2 factorial is 2 times 1. Now we have the last term of our interest, which will be n minus 1 up to n minus 2 over 3 factorial, and then of course x to the power 3. So we have negative 1. For the second one, negative 1 minus 1 will be minus 2. That part, negative 1 minus 2, will be negative 3. And then 3 factorial is 3 times 2 times 1, which is a 6. That's as good as multiplying by 1 over 6. And then our x is negative x raised to the power 3. So basically this is what this part is. So we'll just say plus plus because it's not complete. We can simplify it. So we have 1, that gives us plus x. In the brackets here we've got negative 2. So negative 1 times negative 2 is a positive 2. Positive 2 divided by, let me just write that, positive 2, and then x squared, and then divided by the half there. Negative 1 times negative 2 times that, both are 3 negatives, that will be a negative 6. We have 1 over 6 here, don't forget, and then this, that will be a negative x as well, negative x to the power 3 plus plus. So we have 1 plus x, these 2 will go, so you remain with x squared, and then you have a minus negative times that negative gives us a positive. So equally there you end up with a positive, that positive x to the power 3 dot dot dot. And so that's all we have, and we can actually use that now to multiply with that part. So the first part is 1 plus x multiplied by 1 plus x squared plus x to the power 3. And so that's all we have there at that point. If we multiply by 1, you maintain, I'm starting by that one, so we maintain 1 plus x squared plus x to the power 3. When multiplied by x, that would be x squared, that would be x to the power 3, that would be x to the power 4. So we're interested only in the first 3 terms, right? So we have 1 plus 2x plus 2x squared plus 2x to the power 3. These are the first 4 terms, and that's enough for expansion. So therefore, this is our final answer. Simple and straightforward. There's nothing more, nothing less. So the same idea can be applied to all the other questions that we have here. So it's just the idea of you trying to see how you can manipulate what's on the bottom especially. So we have x plus 2 for the second one. If we bring what's down to the top, 1 plus x will be to be raised to the power negative 2. How can we expand it? Don't forget our formula. And then plus n minus 1, n minus 2, 3 factorial, x to the power 3. Okay, so we have our n in this case is negative 2. That is our x. Our x is x. That one even becomes easier because x is x. So we just go direct. So we have 1 plus, our n is a minus 2, so that's negative 2x minus 2 for a second one. In the brackets, that would be a negative 3 over 2. X remains as it is. For the next one, it will be negative 2 again, negative 3, and then we have a new term, negative 2 minus 2, that's a minus 4, divided by 3 factorial is just a 6, x to the power 3. This one is straightforward. These two can divide. This can give us a positive 6, and then they can divide. So remain with 1 minus 2x. Negative times negative gives us a positive x squared. This is a positive times that negative, it becomes a negative, so that would be a negative 4x to the power 3. So hopefully our manipulations are right. Then we expect of x plus 2 multiplied by 1 minus 2x plus x squared minus 4x to the power 3. We are not done. We can expand as many terms as we want, but we went there. Okay? Because this gives us, we're interested in the first 4 terms. X times 1 gives us if you multiply by x, you're going to have x minus 2x squared plus x to the power 3 minus 4x to the power 4. Multiply by 2. 2 times 1, that would be a 2. 2 times negative 2x, that's a minus 4x. That's a 2x squared. That's a minus 8x to the power 3. That's where we are ending there. I'm just trying to ensure that I'm trying to make your addition of the like terms easy and faster. So we have 2, and then that's a minus 3x. That's a 0. This is a 0 clearly, as I can see. And then x to the power 3 plus that's going to be a minus 7x to the power 3. Okay? And there is, if you are to look at this term, x to the power 4, what's a possible source? There can be a next one there. Since we've ended at this point, are you able to guess the next one? I can guess the next one, so that we can just add it. Since we have a 0 somewhere there, the next one would be all the way up to n minus 3. So this part is negative 2. So we have negative 2, negative 3, negative 4. So now negative 2 minus 3, negative 5, divided by 4 factorial. 4 factorial is 4 times 3 times 4 times 3 times 2. And then, of course, x to the power 4. 4 can divide, remain with negative 1. This 6 can divide, remain a positive 1, since negative 2 times negative 3 is a positive 1. So negative 1 times negative 5 gives us a positive 5. So we have a positive 5 x to the power 4. And then 2 times that gives us 10 x to the power 4, which would give us plus 6x to the power 4. And so the first 4 terms will be 2 minus 3x minus 7x to the power 3 plus 6 to the power 4. 6x to the power 4, if all our manipulations are right. Basically, this is what you basically get to do when you're dealing with such questions. Now, pause the video and try out the last one. We have 1 minus x multiplied by, so we have 1 plus x. Now 1 plus x to the square root is the same as the power half. So we can write that as 1 minus x over 1 plus x raised to the power 1 over 2. Now if we take it to the numerator, it becomes a negative power. So again, we'll start with by expanding this part. We have 1 plus our n is negative half in this case. That's what we make everything different. So negative half multiplied by our x, and then negative half minus 1. So now dividing by the 2 factorial is the same as multiplying by 1 over 2. For the next one as well, we'll have similar steps. That will be plus negative half. Now negative half minus 1. By now we should know that that's the same as negative 3 over 2. Now we also have an extra, which is n minus 2. So that will be negative half minus 2, which is the same as negative 5 over 2. Right? And then we have x to the power 3. Don't forget that here I've forgotten, this is x to the power 2. So that will be x to the power 3. Divided by 3 factorial, which is as good as multiplying by 1 over 6. Since 3 factorial is 3 times 2. So we'll just end at that term. So we have 1 minus half x. This is negative half minus 1 is the same as negative 3 over 2, which will give us positive 6. If you multiply by with this, no, on top negative, so that will be a positive 3 on top. The bottom it will be a 4. We're still multiplying by another half there, x squared. Negative half times that will be a positive 3 over 4. Multiplied by negative 5 over 2. Multiplied by 1 over 6. Multiplied by x to the power 3. 3 there it's 1, 3 there it's 2. We have 1 minus half x. That would be a 3 over 8 x squared. 1 times 5 times 1. we end up with a negative 5. 4 times 2 times 4, that's 8, 16. So 16, that would be x to the power 3, and that's a negative. So basically that's what we have. I'm just hoping we don't have any errors in our calculations. I hope so. This is the power 3. So we have 1 minus x multiplying by 1 minus 1 over 8x. So we've only gotten the first 4 terms in the expansion of the right hand side. Okay, so 1 multiplied by everything remains as it is. So if you use now negative x, what will change is everything will increase by x. So 1 will be negative x, that will be positive 1 over 8x squared, that will be negative 3 over 8x to the power 3, and finally that will be positive 5 over 16 x to the power 4. We're only interested in the first 4 terms, so we'll group them. Constant 1 will remain. This part matches up with this part, so that is negative 1 over 8 minus a 1, right? So that would be negative 1 over 8, which if you take it in terms of an improper fraction, 8 9 over 8. And then x squared, 3 over 8 plus 1 over 8, that's a 4 over 8 x squared. Then this part, negative 5 over 16 minus 3, negative 5 over 16 minus 3, no, minus, this part, minus 3 over 8. So that is negative 11 over 16 x to the power 3. These are the first 4 terms. Okay, hopefully our manipulations are right as well in this case. So basically this is the idea on how you are able to, or you should handle these kind of questions. Just apply this formula of the binomial expansions to manipulate the denominators, and then multiply with the other part, just as we multiply the quadratics, the linear functions that we know. Okay, you can either use this kind of addition, or you can use the previous one that is a bit straightforward, where you write the first line on top, the other one down, and then arrange according to the powers that you have. Okay, so that's it for this question.